Hello, students. Welcome back. It's been a couple days since I last talked to you guys about anything forensic science related. I know we had that Zoom call last Wednesday where I tried to get just in touch with some of you just to touch base, and I try to get. I was hoping for all of you guys to show up. We had four. It's not great, but it's not terrible either. But we just sat and talked for about 20 minutes about what everybody was doing, and I don't think we talked anything forensic science related, just about life in general and how the families are doing and so on and so forth. So I hope to do that again sometime, maybe sometime next week, and we get some better attendance. But we'll get back to forensic science now. And like I've told you guys before, we're in the process of kind of walking through different types of jobs and different branches of forensic science. Everyone knows about the DNA and blood stain patterns and hairs and fibers and tool marks and things like that. But things like forensic odontology and forensic psychiatry and all of those things, those are a little bit different. Those take a little bit more specialized form of education. And a lot of the individuals that are doing forensic entomology are going to be doctors or have some sort of doctorate in entomology and in insects and bugs and things like that. So, if you ever watched the original CSI show, there is a show in season 6, I believe it is. It's called Secrets and Flies. And I tried to find it, the snippet, the very end of that, when Gil Grissom's on the stand and he's trying to refute testimony from a expert in entomology. And they go back and forth on how they came about their conclusions. And it's a great scene. It's about 5 minutes long, but you had to watch the whole show to get it, and I couldn't do that. So, and there's a line in there that says "Dead men do tell tales." Okay, and what he means by that is when a person dies, there is a very systematic, a very progressive form of decomposition for the body itself and for the organisms that surround the body. Okay, you got to think about it. Every organism on the planet has to eat. Okay, and they've got to reproduce. Insects like bugs, like flies and beetles, those guys, they're scavengers, they're decomposers. Their main job is to find dead organisms and feed off of them and use them as part of their life cycle. That's where forensic entomology comes into play. It's the idea that if you understand the life cycle of an organism, you can use that and apply that in a court of law to basically build a timeline for a court case. All right. So what is forensic entomology? By definition, it's the application of insects to legal issues. Okay. Entomology itself is the study of insects. But again, if you know the life cycle of certain insects and what they do to a cadaver or a dead body, you can apply that to a court of law, and build a timeline as far as, if you look down at the death investigation, establishing timelines, the time of death since the time of discovery or the post-mortem interval. We'll talk about that a little bit later on. You can use it to help understand the movement of the corpse, the manner and cause of death. That's very important. If you understand that there's might be multiple crime scenes based on, an insect is found inside the body that shouldn't be there or is found in a more natural area than where the body is, now that's going to lead you to a different crime scene. The manner and cause of death, location of the death. If you have insects that are centered around the head region, maybe you have some sort of trauma to the head. If you have insects that are primarily in the abdomen, maybe you have some sort of wound or death to that part of the body. So it gives you cause, manner, and movement of the corpse. Association of suspects with the death scene. Again, if you've got insects that are very, very specific to certain parts of the world, certain parts of the county, or maybe come out at certain parts than where the body's found, and you can link a suspect to a crime scene, maybe the insects found around that suspect can link them as well. Detection of toxins or drugs. This makes sense if you have a body that's might be an overdose of heroin, and as soon as that body dies, let's say it's someone who's walking home or taking a drug out in nature and they overdose. As soon as that body dies, they are fair game for all kinds of insects. And if there's drugs or toxins in the body, those insects are going to start to feed off of that body and ingest indirectly some of these drugs or toxins. Again, that can be used, in your studies of entomology. If your larva of a blowfly has traces of heroin or traces of methamphetamines or traces of cocaine in it, you can rest assured that that means that there are traces of that drug inside the body. Okay, so establishing a timeline is very important. Movement of the corpse, location of the corpse, the manner and cause of death, association with the suspects with the death scene, or in detection of toxins or drugs. Okay, now let me scroll down here. I want to talk about the post-mortem interval. This interval, this concept here, is the elapsed time from a death to the discovery of the cadaver. And this elapsed time could be 5 minutes, it could be 30 seconds, it could be 30 years, okay? But that interval, there are certain stages that are going to take place on the decomposition of that body that help build the timeline, okay? And if you can build the timeline, you can start putting suspects in that timeline and placing them where they go. Certain flies, certain beetles can be vital in determining the post-mortem interval. Okay, even in the fly group, there are certain flies that will lay what are called smooth maggots that typically show up first. They arrive first. They show up first. And then you have a group of flies called the hairy maggots that show up a little bit later. And the maggots of a hairy fly, or the hairy type of maggot, tend to be predators of the smooth maggots. So if you've got a corpse that's full of smooth maggots, that's a certain timeline. If you have a corpse that is a combination of smooth maggots and hairy maggots, again, that places that timeline a little bit later. If you have a corpse that's full of hairy maggots and a few beetles, that's going to put that timeline even farther back. All right, so it builds the timeline. All right, and again, insect, this last line here, this is probably the whole presumptive thing of why entomology can be used in forensic science. Insect development is predictable. The decomposition of a body is predictable. Okay, that's important for forensic entomology. Okay, so let's look at first the decomposition of a body. Okay, there's 5 stages when a body dies, or when an organism dies and the body is left there in any state, anywhere on the planet. There are certain stages. Stage 1 is called the fresh stage. Okay, and when you look at this, it commences at death. It ends when bloating is first evident. Okay, so inside the body, you've got certain chemical processes that are taking place. And then once those chemical processes are done, those processes are going to start to break down proteins, carbohydrates into simpler compounds. And that's going to generate gases in the body. Okay, so when that body starts to develop these gases into what we call bloating, that's the fresh stage. The bloated stage then is when you have so much gas buildup, they start filling up the abdomen. Okay, so not just the stomach, but the belly of that carcass starts to get bloated and extended out, and you start to get some putrefaction. This is when you start smelling the body. Okay, and when you watch a TV show, so the body smells. That's the bloated stage of decomposition. Then you get to the decay stage. The abdominal wall breaks, allows gases to escape. The carcass then deflates. So the carcass goes back to, or even probably smaller than, its original shape. Again, a very, very smelly, disgusting stage here of decay. Post-decay is 10 to 15 days later, or 10 to 25 days in length. Dry habitats remains the skin, cartilage, and bones. Okay, in wet habitats, wet viscous material in the soil under the remains. All right, so depending on where the body is found, and by this time you're going to have all kinds of insects and other things feeding off of the body, and you're going to start seeing some of the effects of those decomposers. The dry stage then, mainly bones and hair remain. The odor is primarily that of normal soil and litter. And a forensic anthropologist, if they're called in, they're looking for a body that's 10 years old, all you're going to find there are bones. You're probably not going to find hair. But if you're looking for a body that's 6 months old, you're going to find bones and some hair there. All right, so those are the stages: fresh, bloated, decay, post-decay, and then the dry stage. The University of Tennessee has what's called the body farm. University of Tennessee has excellent education in forensic science, but they have a body farm, and this is what they do: is they will get cadavers, they will get bodies that are recently deceased, and they will study them at each stage of decomposition. They will bury them in different temperatures. They'll bury them in different environments, and basically study them and how they decompose, and use that to further advance the forensic entomology. A couple pictures. This is the first stage. This looks like some sort of baleen whale that's washed ashore accidentally, obviously. I don't know what's happening here. Here's the bloated stage. They're trying to haul this whale through the streets. Looks like Japan or China here, and over time, it looks like this whale has exploded. The gases in there have caused the abdomen to explode, and now you've got a mess on your hands. Who wants to ride that scooter? Not me. Once the gases have escaped, everything just kind of collapses back down around the skeleton of the animal, and you get the decay stage. Everything's starting to decay out. Okay. Well, it's during this decay stage that we're going to start seeing major groups of insects to kind of start to show up. All right. As soon as the person dies, okay, that body is fair game for any decomposer. Could be a fly, could be any one of these types of flies here. It could be the blowflies, the fresh flies, the house flies, the cheese skippers, whatever. Or a little bit later on, the beetles start to show up. All right, so a body is fair game. This is natural selection, okay? And these organisms, they're decomposers. They're looking for a meal just like anything else, okay? It's the presence of these animals and it's the life cycle of these animals that are predictable. And that's where we can use in a court of law. If a blowfly lands and starts laying eggs that turn into maggots, there's a certain very particular time frame for that. A cheese skipper, I've never seen one of those. This first I've heard of them. But if a cheese skipper is found, okay, it lays eggs, they turn to maggots, they turn to larvae, there is a sequence of time that this happens. The carrion beetles, the dermestids, the scarab beetles, if they're present, there is a particular timeline that they show up in, okay? That's the important part. So if you look at, the carrion beetles, for example, the first beetles arrive at a corpse soon after the body begins to putrefy. So this is going to be in that decay stage. Flies, on the other hand, prefer fresher meat. Okay, in contrast to the flies, beetles have chewing mouth parts that can manage tougher foods than the semi-liquid material that a fly larva are so efficient at exploiting. Okay, so flies tend to show up first, and then the beetles come. If you look at the maggots, the story the maggots tell. Blowflies, maggots are in two forms, what we call smooth maggots and hairy maggots. Okay, smooth maggots belong to pioneer flies that are purely corpse feeders. Okay, so for the most part, these pioneer flies are going to be the first ones that show up on a dead body. All right. Hairy maggots will often feed on corpses, but they're also active predators that feed on smooth maggots. Because of that, because they're predators and they're going to feed off those smooth maggots, they have to show up a little bit later. Okay, if their primary source of food are these smooth maggots, they have to wait for a colony or a population of those maggots to show up before they can show up and feed off of those smooth maggots. Okay, so you've got the pioneer flies that get there first, and they're going to lay their eggs that turn into smooth maggots. After that, once you have a population of those maggots present, now you can get some of these hairy flies to show up with their hairy maggots to feed off the corpse and the smooth maggots. And then you get these beetle maggots that also show up, and they'll kind of do the same thing with the adults. All right. So again, it's all about building a timeline here. So let's look at the blowfly life cycle. A forensic entomologist, for every insect out there, he knows the exact life cycle of these insects. Okay, so here's our common blowfly, fairly large. They've got that shiny bluish green teal tint to them, fairly large. If they sense or smell a dead body, they will land on it. and they will start laying eggs on that dead body. Okay. The timeline from egg to the first maggots is 23 hours. Okay. That's the timeline. So if you're finding, eggs of a blowfly on a body, that's, and they haven't turned into maggots, your timeline here is from 23 hours down to 0 hour. Okay. From the first maggot to a larger maggot, you're looking at another 27 hours. From this medium-sized maggot to a large adult maggot would be another 22 hours. From maggot to larva, okay, the pupa stage is another 130 hours. And then the time it takes for that pupa to metamorph, to change into an adult blowfly is another 143 hours, okay? Now, what you have to take into account are the environmental factors. Under normal environmental factors, 70 degrees Fahrenheit, perfect growing conditions, 23 hours, 27 hours, 22 hours, 130 hours, 143 hours. Knowing where these insects are in their life cycle gives you an approximate timeline on when the crime occurred. Again, you're looking at the insect family here over on the left-hand side, the blowflies, the carrion beetles, the flesh flies, the clown beetles, love beetles, sap beetles, even down here, the museid flies, the rove beetles and things like that. Okay, when do they show up? Okay, you're going to see these blowflies and these certain flies and beetles start to show up in the fresh stage between 1 and 2 days of death. And then you get the larger population starts to develop here. Okay, so again, look at the timeline here. Our blowfly being one of the first ones, and these museid flies being the first ones, probably laying smooth maggots here. So they show up, and then they really get to work on the bloated stage. Midway through the decay stage, they start to decrease, and they start turning into flies in the dry phase. Okay, but again, look at the sap beetles and the checkered beetles. They're present in the bloated stage, but you don't see a huge population until late in the decay stage. And even down here with the tummel beetles, okay, they're the last ones to get there. They're the ones that are cleaning everything up. All right, so again, this is kind of the end of the information here. The biggest thing here is when I go back up, death investigations, you can use this information to build the timeline. It's not going to be the end-all, be-all, smoking gun that's going to put someone behind bars, but it's going to really help you build a timeline as to when a body was killed, and then from there we can start piecing all the puzzle pieces together. So this would be more of a class characteristic, a circumstantial characteristic, but it's still very valuable and can be used in a court of law. Okay, so I've attached 10 questions to a Google form. Some of the questions can be answered from this video and from this timeline here. Some of them you're going to do a little bit of research on. So shouldn't take you very long. Just 10 simple questions, all of them multiple choice.